Okay, so hopefully on what we learned in class today and through the videos that were posted, hopefully I can take a good approach to this. So this is for the, hopefully I don't, this is for relativity 0.04. And the question asks, hopefully it's focused. A space station sounds an alert at time interval 1.00h, and the spaceships A and B pass the station, both moving at 4 c naught relative to the station, and both in opposite directions. And so it's asking how long is the time interval between the signals in accordance to observer on A, so spaceship A, and then asking how long in accordance to observer on B. Oh, goodness. My spaceships are just lovely. Okay. Hopefully those look like spaceships and not, hopefully, they kind of look like sea creatures to me or something. Anyways, so, and then C asks, at what speed must A move relative to the station to measure a time interval of 2.00h between signals? And so we learned that, so I'm going to do it in relation to A first, as that's the first question. And so change TA, change in time is equal is equal to the proper time divided by 1 minus v squared c squared. And so the c, I'm guessing, is c naught. That's just a different way of putting it. We didn't put it as c naught today, so I'm just gonna guess that's what that means. And so the proper time interval is given to us. It is 1. That's nice, which is usually what the gamma is, as gamma is 1 divided by 1 minus b squared c squared. Okay, so 1 minus, in this case, one minus, I should always have my calculator out so I don't have to so hopefully I want to look at the text to make sure. Okay, so space station. A space station sounds at the alert. Yeah, so 1 hertz, 1 H. I miswrote this. It is 0.400 C naught. I think that's what it is. Yeah. At what speed? Yeah. So, okay, back to what we were doing. So we're doing change TA equals 1, which we get from right here, divided by 1 minus, so it's saying both are moving, so V squared is 0.400. So we're going to say 0.400 squared, right? Yes. And then we're going to do the math of that, which is, sorry. Oops, I just turned my calculator off. Come on. 1 minus 0.4 squared. And then we need to square root that. Then divide it by 1. Whoop. Okay. So I get change in TA is equal to 1.091, which we'd say 1.09 H. Oops, you can't even see what I'm writing. So that is, so how long is the time interval between the signals in accordance to observer A? So that means observer A, it's 1.09 H. And then, so that's the guy, that's the guy in A. And then to find the guy in B, that's going to be the same thing. They're just moving in opposite directions. So change in TB is going to be 1.09 H as well, because the time interval, so the T proper is equal to 1.00 H. That's going to be for, in both scenarios, spaceship A and B. And both are moving at 0.400. So both are moving at the same, just in opposite directions. So, yeah, so, and you can't have negative time, so even though they're moving in opposite directions, you're not going to say negative anything, so negatives don't apply here. And then the third part of the question is asking them relative to, so move relative to the station at time interval 2.08 or 00 H between signals. So that now means that time TA is going to be 2.00 H, which is going to be equal to the proper time, which is 1 H, but we'll plug that in later. 1 minus B squared C squared, square rooted. So that's 2.00 H equals 1.00 H divided by 1 minus B squared C squared. And then we're going to say 2.00 H, or no, then we can cross multiply here. That would be smart. So we get 1.00 H divided by 2.00 H equals 1 minus B squared C squared. 1 divided by 2. Oh, but this would be squared, right? Because square root I think. Yeah. Because it's going to be 1h. We're going to square both sides. Cancel that. Yeah, so 2.00 squared equals 1 minus v squared c squared, to get rid of that square root. And 1 squared is just 1. Well, now I've written the same thing twice. Okay. Hopefully that logic makes sense, because you square it to get rid of the square root right here. And then 1 squared is just 1. So you get 1/4 equals 1 minus b squared c squared. Then we're looking for v, right? So v is going to be equal to c fourth times. Okay, wait. So let's just put v squared c squared equals 3/4. But then we need to get rid of the squared. So we're going to do v squared equals c squared 3/4. But then we're going to square root that. And we're going to get v equals c times 3/4. And so that is going to be equal to, the square root again. So VA, I should put A, is equal to 0.866 C naught. I don't know why they do that C naught thing, but I don't remember us doing that in class. Okay, so that's relative to A. Oh, okay. Okay, so how long is the time in between, time interval between signals according to observer A? So going off of observer A, I'm just kind of going through again. We got 1.09, and they're the same in opposite directions, so that entails that the time interval for B is going to be the same. It's just going to be in the opposite direction, because they're traveling at the same speed of 0.400 C naught. They're just in opposite directions of each other, but you don't have negative time. So, and then it asks, at what speed must A move relative to the station to measure a time interval of 2.00 h? So the space station sounds at 1, so we know that's the proper time. So we plug that in. So 2 equals 1 divided by 1 minus b squared c squared square rooted. And then we want to get, well, we want to simplify it. So we're going to square both sides to get rid of, we'll cross multiply and then square both sides, and we get 1 squared divided by 2 squared equals 1 minus v squared over c squared. And then that gives us 1/4 minus 1 equals 1 minus v squared over c squared. And then we get that by itself. So we end up with VA equaling 0.866, C naught. Yeah.